Okay, so we'll have a look at debugging now, and this is one of the most powerful things that you get from using a IDE like Visual Studio. The debugging capability is something that I wish I kind of caved to a lot sooner. So when I started developing as a game developer, I was classic, you just use print statements, right? I mean, yes, they are useful, but I continually hesitated to start debugging. Part of it was because I didn't know. I'd done it before, but it'd been around 8 years since I'd done it. And I was streaming learning Unreal Unity at the time in C#, and everyone's like, "Oh, why don't you use debugging instead of print logs?" I was like, "Oh no, it's easier. You know, this is only quick." But I'd make up excuses, and the fact was, I just wasn't super confident debugging. And it's one of the one bits of advice I would give to newer devs or devs who don't debug is to get over that little bit of a hump and use the debugging tools, because they will help you so much, and like it's a massive part of development. So I'd recommend using them. So in Unreal, you can debug. You can debug in that old way. You can do some print logs if you want. It's definitely, no one's going to stop you from doing logs if you want to. So if we want, we can go ahead. There's two ways to do logs. You can do your UE log like this. If there's a log defined, you can use a certain name for it. You say the type of message you want is either going to be log, it can be warning, or it can be error. And then you would go ahead and write what message you want it to say. And so this is an error. So you can do that. That's no problem. And they will come out in different colors. Errors will be red. So that's the old school way of doing it. Another old school way, if you want it to show up on the screen when you're in game, you can get a colorful message. So if you're doing it in Blueprint, you can do print line. Oh no, what's it called? Print string. There's a function in Blueprint that you can call it. It puts a message on the screen, like so. Print a debug message. That is. You can achieve that also via code. So I think you need to include a engine possibly, but effectively you can make a string however you want. So let's go ahead and do. Oops, my debug string. No, not the. It's not about me, right? Okay, and we can go ahead and make this with some of the helpers that you have in Unreal. The printf one is good because it allows you to kind of whack in. My var is this sort of stuff where you would then give it whatever variable you want. I don't know. Probably let's just say we've got in card to transform dot get name. It's probably something like that. You see, we're not getting that much autocomplete at the moment, and that's one of the things with why I do end up using Visual Assist. It really helps with the writing of the code. So you can do logging in this way as well. If you write your message, you can then do gengine, and you might want to check that first, but it will typically, if gengine's not there, you've got bigger issues to deal with. You can do a print on-screen debug message. There we go. You can see we're getting a bit of IntelliSense here to help us here. So, and you would go ahead and I'm not going to explain how the whole function works, but you can go ahead and give information about like how long you want it to be on screen. You can give it information about what color you want it to be. So we might want this to be red. And then I think we can just pass in our message yet. So we can put in the debug string then. And there's a few more parameters that you put in. But yeah, essentially, if you were to go ahead and do that, this is just an example I had earlier, so I just want to finish it out correctly, just because it lacks the IntelliSense as much as I'd prefer. So I just want to copy out bit for bit so I don't give a false example. Yeah, if you put something like this, this would go ahead whenever you call this, and it'll write that print message on the screen. So this is the older ways to do it. Yes, Brainoid, you are correct. Apologies. I would need the text in the printf. You are correct. The text macro. Thank you. That was an oversight by me. Yeah, so these are two ways that you can print with logs. Let's just comment these lines out. Okay, now realistically though, you should be debugging using the debugger. The button you press from Visual Studio every time to connect to your game via the editor, this allows you to debug. It's super handy. So let's go ahead. We'll do it and we'll have a look at some of the recommendations while debugging. So if you remember, the editor will change kind of color when you've gone into that debugging mode. So I've told it to build and then to debug attach. So it'll launch your instance of Unreal Editor and then it'll automatically attach to that instance of it as well. So then you're instantly ready to debug. You can chuck in a breakpoint and it will hit that breakpoint whenever the code hits that line. So let's just let this launch up and then we'll go through. Oh, we've got some syntax errors from me messing around by the looks of it. What did I break? What did I break? Okay, let's undo. Oh, it was that old line from earlier. Okay, that was the one I did intentionally earlier. And I never fixed it. Well done. Let's launch this again. Oh, crikey. We're getting a debug session for free here. What have I done? So it's complaining that I haven't changed this file though, have I? Pretty sure. Do you know how we can check what have we changed? Yeah, you can at this point, just for the sake of compiling, I might just revert everything that I've got just because I may have changed stuff on showing examples. So is this just undo changes? Yeah, let's undo these. Oh, don't worry about that. That's fine. Undo those. Even though we're going to lose our log messages we wrote now, it's fine. Okay, that should have undone all of that. Let's try again. All right, cross your fingers. Not even looking at the output window. I can't face it. Although Unreal does have that magical ability of, coding in Unreal and CPP has that magical ability of sometimes if you don't include something, it'll just happen to work because it's included in another file. And the order that everything was compiled, it already knew about it. But then, so on another machine or further down the line, you can compile it and it does it in a slightly different way and then it throws an error as well. So I was worried it was going to be one of those things, but thankfully it's not. Okay, so if you remember right at the start, this was why I said that it's good to get the debug symbols for the version of the editor you're using, because that'll allow you to breakpoint not just your own code, but also it'll allow you to breakpoint the engine code, which is very helpful at times depending on what you're having to debug. But what we'll do then is we'll just go into a normal game. And we will hit some breakpoints and see what happens. So as I said earlier, we are attached to it. That's what the stop symbol means. Just as a warning, if you press stop here, it closes the Unreal instance. You can get around that, and I'll show you that in just a moment. But ultimately, when we've launched with this play button, we are already attached to it. So if I want to go ahead and let's... okay, so I haven't configured my... Remember I said the window changes when it goes into debug mode. I haven't got my bookmarks bar out here, so I'm probably just going to get my bookmarks. I still use the bookmarks even in this view sometimes. So I've got my bookmarks here. That's handy enough. I might also put my Solution Explorer like I did last time just on the side of that to give myself a little bit more space to work with. Because I tend to use most of these. I'll talk through some of them in a moment. But we're just going to go ahead and chuck a breakpoint somewhere here. End turn. So we'll just play one round of a turn. Or I might even call it right at the start if I remember. So let's start our run. Okay, we'll take a quick turn. We'll play a character, do some attacks. Wonderful. We will do a special with our priest character. they're healing a character who doesn't need healing. I guess it doesn't really matter, does it? We just need to end it. So let's go ahead, do an attack. We'll wrap up our turn. And now we hit this breakpoint because we put on a breakpoint in the side. Now, this means you are able to stop the code at this moment in time, and you can essentially assess the state of variables and memory at that point. And you can even kind of progress it one tiny step at a time, which is very, very useful. So let's look at what we've got on this debug screen. So we now have this debug kind of toolbar area enabled, and this gives us tools that will allow us to jump through. So the main ones that I tend to use is this F10 to step over. What that means is it'll go to the next line. So I press F10. You can see that it's moved me down because it's active. You can hover over it and get the value of it. It's true, so it didn't enter this statement. So this breakpoint is just where it stops, but you can still remain if you just use these tools. If you press continue, it'll carry on running until it hits the next breakpoint. But while you use these tools up here, it allows you to jump through and just go line by line and assess the state of things. So first off then, let's see what we've got. We've got these buttons to jump around. I sometimes use this as well, the shift F11 to kind of jump out. So here we've got a function, get is board game locked. If I pressed F10, it will just jump to the next line of code. So if this is probably false, so it would just go to this next line. But if I want to know what this function does, I press F11, it will jump in to any function call that happens on this line. So I hit F11, it goes into this, get is game board locked, and it does some check to check. Let's go ahead and press F10. The lock count here is 0. It's not greater than 0, so great, it's not locked. Now, if I wanted, I could press F10 a few times, and that would allow me to naturally go back to where I was, because we're at the end of the scope of the function, so it naturally returns up. But if you want to jump straight to where you last F11'd in, you can do Shift F11, and it jumps you back out to where you were. You haven't gone backwards in code. Remember, it's still executed what was in there, but it just takes you straight out to where you were when it was called. So that's how you would use these. F10 to go down a line, F11 to dive in, Shift F11 to dive out. I tend to use the hotkeys rather than these buttons up here. So the next thing I should point out then is we can have a look at all our breakpoints. So if I press, there's a breakpoints window. If it's not open in debug, you have a separate window menu. So I know most of our kind of menus have been in here before in view, but debug has its own special one. So in here is where you would enable breakpoints. But we'll have a look at what we've got in here, and we'll turn off a few windows as we feel we need to. So here it will give you a track of all your breakpoints. What a lot of people do, including me, is when they don't need the breakpoint, they'll just go, oh, I might need it later. So instead of clicking it to get rid of it, what they tend to do is just use this disable breakpoint, thinking I might need it later, so I'll leave it there. And what tends to happen is you'll end up somewhere else miles away in your code, and then you'll forget it, and then you'll open this breakpoints list, and you'll have 100 different breakpoints in there. So it's quite good to make sure that you one can jump to different breakpoints when you actually want them, but two, it's good to kind of manage and remember those that you may have forgotten about. But yeah, this shows you your breakpoints, and it allows you to turn them into I guess more intelligent breakpoints as well. But we'll talk about the different types of breakpoints in a moment. So let's look at the other windows that we've got. It automatically split in two for us. So we'll start on the left, autos, locals, and I'd say watch is kind of related. So I'm going to bring that across. With threads, I think it takes a while to load now, so I might stutter. Generally, I've never needed to use this thread one myself. I just close it down. The same thing with modules. I've not needed to use modules, so I just close that down as well. So autos and locals. Effectively, autos is Visual Studio trying to be clever and giving you a look at some kind of variables and members just to based on where you are in the code. Quite a lot of the time this is useful, but this allows you to, you know how I hovered over is active earlier, you'll be able to find that member in this section down here, and you can look at the data there if you'd prefer not to hover over. So for example, we need to evaluate is player party at the moment. So I can hover over it as we've done there, but also you can see the autos automatically pick that up for me, and it goes, oh, you might want to know what that is there. Because we also use current party, which is an object that stores that information, it shows us that as an auto. And this is where, if you really want to drill down, you can do this in this menu as well. You can open up a bunch of menus and menus and menus and menus and menus. But yeah, thank you, Brainode. We'll make it a little larger so we can see it. what you can do here is you can expand on it without worrying about your hover space going somewhere else. Because that's what I tend to do. I tend to go through this, and then if I accidentally go off of it, I lose my progress, right? Or if you want to click somewhere, you know, this is super handy. So this allows you to look into the structure of something if it's that type of member, if it's a pointer to something, right? So I can then go ahead and look at specific areas of this. So I might want to say, okay, at this point, this is the current party. Maybe I want to go and have a look at the party members. And okay, so there's 3 party members. The first one here is, okay, so we can see all the information about it. A lot of information we probably don't need, but the character type, it's a warrior. Great. So then I can close that down. And then I can go, okay, this one's the bard. So you can kind of investigate the state of stuff when you've stopped. And that is really useful when you need to. Now, that's autos for you. Locals will just give you access to this entire scope that you're currently in. So this is the instance of this game card manager, and then you're going to get every single member in here. So these are members that belong to this class. And then up here, when you've got these yellow icons, that means this is, you'll find the members that belong to the parent class. So this is a derived class of actor. So if I click on this arrow, I can then go ahead and look for anything. And now actor is a huge class. It's one of the main base classes of Unreal Engine. But this is one of the great things that was added in 2019 is that you can search in here. So one thing quite often you want to know is maybe if you're looking at a component, you might want to know who is the owner of this component, or what is the outer, for example. Sometimes you might be looking for like a transform, a location, and you can use this search to find things. I think as far as Unreal networking goes, you do sometimes care about something called a role. So you can search for roles, and you can do a search depth as well, which means like how many layers down would it search. This being one layer, so UObject would be another layer, or jumping into these kind of every time we have to expand the carrot, so to speak. So we can go ahead and search for role, and it will find us. We can click through them and find them, and there we go. We found what the remote role is there. Because they're not alphabetized, it used to take so long to go through this list and find this stuff. So this is one way you can do it, and you notice you can pin these things as well. You can pin it as a favorite member. I think what that does then is it'll bring it up to the top, if I remember correctly. Yeah, and I think that remembers it next time you go in as well. You'd need to check that yourself, but I'm pretty sure it does, which makes it really handy when you've got some of these larger classes. So that's super handy. But really what you can also do is use the watches for that. So watch by default is empty. That's where you add stuff. So you might go, right, okay, next time I come into here, I don't want to have to go through this massive structure each time. So how about I just watch this instead? So you can say add watch. That then goes to your watch value. You can see it doesn't call it this. It doesn't call it the exact names that we saw before. It's kind of talking about, it describes how it got there. So it's like, it is an actor pointer. We cast this object, which is card game manager, to an actor pointer so that we can access the actor members, and then we get hold of the role member. And so whilst you're in a kind of in an active scope of debugging where that cast can work, it will tell you the value of that. So that's super handy, because that means every time that I come into that end turn, I can look straight at that value again. So let me just press continue. We'll go back to my game. The enemies will play out their turns. The rats, conniving rats. Hopefully they won't kill my party. So there we go. Bites the poor warrior. Critical strikes the priest. Okay, so now if it's my turn, we'll just press end turn. Just so we... What happened? I think I removed my breakpoint, didn't I? I did. See how I did the disable thing? Okay, we'll whack that back on so we can hit the breakpoint. Sorry for the delay. Okay, so the end of the enemy turn, it's hit this breakpoint again. And what's nice here is we can just easily check in our watch list now to know the state of this, so without having to kind of go through the whole way. It's really, really handy. It makes sense if you're debugging a certain section that you just kind of watch a few variables that are important to the kind of logic that you're trying to understand. It makes it easier than having to go through all of those. But the pinning can also achieve much of the same thing as well. Yeah, so that's really handy. Definitely make use of these. For a long time, these were windows that I never touched. other than this one. But I think it is handy to understand that you can kind of take control and make it easier to navigate this, and using the search is very, very useful as well. Okay, so this is the first windows that are on the left, and if we keep going across, we've then got the call stack. This is probably the most important thing for me when I'm debugging. So, because debugging isn't always about fixing a problem. So one of the good bits of advice I have from one of my seniors when I was getting into game dev initially is I wanted to know how something worked in a code base that had already been written. And what I would do is I'd find the right class. I'd say, oh, well, what's the classes involved? Get the class names, and then I'd try and follow it. So like we know that begin play is in Unreal is one of the start points for an object. So I'd read it and I'd go through and I'd be like, right, what does this do? Okay, here it creates card game AI. So then I'd press F12 to jump to that, and then I'd read down the code and I'd write in a little notepad the flow, and that's useful maybe to build up a mental kind of note of the kind of structure of the code. But it'd take me ages. I'd be writing notes about it all the time. Essentially what my colleague said to me is you might as well just chuck in a breakpoint somewhere. So say we wanted to chuck in a breakpoint here instead. Let's go ahead and press continue for now. Stop this version of the game, and then we'll press play. When it hits this point, you can use the call stack to see how did it get there. So we can see here, we're currently in create card game AI. Before that, it was in begin play, and it'll take you to where it was last. Before that, this is where it goes into the engine code now. It was in a actor, and this is the logic that goes through all of the actors in the world and calls begin play on them after they've been, or maybe it's actually after it's been spawned in. My mistake. Yeah, notify begin play by here. So this is going into the engine code here, and you can see it goes back from when the world started. So once the world is ready, it then calls begin play on all the actors within it. So you can trace things back, and obviously we're not interested in how Unreal is set up for this particular issue, but it's a really good way for you to get an idea of the flow of logic. Let me just give a better example then. So if we go into character card, the character card, if I remember correctly, is set up of there's like a character info. So let me just control KO to jump to the header of this. And I think we have a little Unreal bug where let me just continue so we can get rid of that little floaty bit there. So if I remember, yeah, character type. So there's something called like a character sheet in here, I think. So let me just go in and search for character sheet. And we'll F3 through to find, okay, so we've got a set character sheet. Yeah, okay, so let's go into character sheet as the class. So I'm going to just F12 to jump into that. Come on, you can do this. That's one of the other reasons that I like. I do tend to use Visual Assist. Is it can parse your code when it starts, and so all of this stuff is kind of ready for you. So it's a lot quicker for you to kind of just drill down into the code. So do bear with me while it opens this file that I haven't had open for a long time. Here we go. Okay, so we're in the character sheet now. And how this works is it's basically a sheet that stores what your base stats are, and then what your current stats are. So I might have 10 health, and if I lose 5 health, I'm then on 5 health, but I still want to remember what my base health is. So let's have a look at when we change a current attribute. This is how like health is changed. So if we have 12 to jump into that, and we can chuck in a breakpoint here to say, right, okay, whenever anything is going to change one of my attributes, I want to know about it, right? So let's now go ahead and start. So we're hitting this right at the start, and we can see, okay, why are we hitting, what is the character sheet getting changed? And we can see, well, when the encounter starts, it calls set up the game board, and then it sets up the party members, and then it's setting up the characters as dead. It must do that initially before initializing them, perhaps, and then that's changing their attributes. And so what's nice is, well, we can see what has been passed in. It's setting the vitality to be minus 100 on dead characters. Don't judge our code, all right? It's fine. But then what we can also do is, not only do you see the path, but you can actually jump to the state of memory at that time. So when I jump back, you see the green arrow changes to here. I can then go in and like look at what the state of things were at this. So you can see it's classified as an unwrapped character coming in. And I can even go back all the way to like start encounter. And I can look at what the state of some of these things were at this point. So this is now player at this point in time. Because, yeah, you can see it got set to player. So by the time it got to here, start game mode was called player. So it's very handy for that. And what we'll find now, we will probably hit this breakpoint another time. So let's go ahead and attack. Let's just go for a simple attack. So now we've got to hit the breakpoint again. This time we're hitting it because we're going to be, let's have a look, shall we? So, well, instead of just hovering over them, we can look at the autos like I mentioned earlier, right? So what have we got? It's saying the vitality is coming in. -6 is what they're changing it. So they're getting hit for 6 damage. Great. And we can have a look what the current values are. So vitality is currently 8. So we can kind of F10 through this. We can go through. And here we go. So I think it's updating the values now. And now you can see that the new value, it changes any values that have changed. It highlights in red for you. So now if we want to look at our current list of attributes, you can see our vitality is now on 2 instead of 8. So you could just kind of breakpoint through and follow the flow of code. Super handy. And what we'll see in this call stack is that it came from a different direction this time. So it's a great way to kind of just understand like how is a part of your code used when you're just exploring a new side of the code base, I guess. So if we followed this one through, we can see it was from a slot card. So a character was played on a card. It happened to be a threat card, which is one of the names of our abilities. It then caused an attack target to be called. And then the receiving enemy tried to receive some damage. It tried to dodge or receive damage. It turns out it took damage, which then calls change current abilities, which brought us to exactly where we are now. So yeah, it's a really nice way to understand the flow stuff. And I wish it was something that I picked up a lot earlier. While I was learning and debugging stuff. Okay, so that's the call stack. We're going to go back to our breakpoints now, have a little look at this. So here I've told you that it lists all your breakpoints, but it's actually more useful than that in my opinion. So you can see that we have this hit count. This is less useful in this example here. Let me just go and do another attack. So can you see current? It tells you how often you've hit the current breakpoint that you're at. So that's really handy for you if you're actually tracking how often something is happening. I don't use it a terrible amount of times, but it's worth pointing out here. But what I tend to do on this is I set up my conditional breakpoints. So let's say that this breakpoint, I only want it to do something if a certain condition is true. So let me just go in and I can change the settings of this particular breakpoint. And I can say I only want it to happen when a certain condition is true. Okay, we've unfortunately hit an unreal breakpoint at the moment, but hopefully we can continue past that. Okay, yeah, we're still alive. Let's go back to where we were. The hit count is good for optimization. Oh yeah, so if you want to see if something is being called a massive amount of times, yeah. Because I'm wondering actually, does it still track the hits if the breakpoint is disabled as well? I'm not 100%. Something I could have a look at sometime. But right, character sheet. Let's go back to where we were. So you can write a condition here to say, right, this breakpoint should only be hit if a certain condition is true. So we could say, right, if, let's just say in delta is equal to -6. All right, so we press close on that. That's happy. You can see our condition has been written there. So this is only now going to hit whenever the amount of something that's changing, it doesn't matter what attribute, it's going to, when it's -6, it will count. And we know that one of our characters hits for -6. So we can actually test this out now. Oh, it's because we're alt-tabbed. Don't worry about this message. We have a current bug in our game where when you're alt-tabbed, all of the cards fly up towards the camera indefinitely. There we go. We're back in business now. So let's end this turn. So this is the end turn breakpoints, and I'm just going to disable that one quickly. Like that. Uh-oh, one of our characters. Did they die or have they bugged out? It's okay, we still got the enemy who can hit for 6. Yeah, we're getting some UI issues at the moment, but don't worry about it, it's fine. Oh no, I can't click anyway. Okay, let's try this again. They're bugs in our game. Don't worry about that. Okay, start demo run. So if you remember, I set it up so it should only break when we hit for 6 damage now. Let's hope that we don't crit. We don't have a chance to crit, no worries. So if I hit this, okay, they lost 2 health. It did go through that code, but it didn't hit. But if I do this one, huzzah! This value is -6, so it does hit it. It's really, really good. Especially, this is really useful if you're kind of... You can't really put a breakpoint because it's happening all the time. For example, a tick. So if you've got a tick that hits every game frame, you don't want to be clicking through every one of those waiting for a value to change because you can't control the game at the same time. So that's where kind of conditional breakpoints, or you can do things called data breakpoints as well, which are really useful. But we probably have to, yeah, based on how long we've been going, I can maybe do a debugging in Unreal session properly another time. But yeah, there's definitely a lot of debugging tools that you can use that makes it a lot easier to debug. One of those conditional ones is definitely one of them. So something with this conditional that I will just point out since we went into it would be, you can change it when it's true, but you can also change it when it's changed as well. And what that means is when this is no longer true. So, or when it is true and when it isn't true. So you'll get a start and a finish. So what is interesting here, so if I close that and we press F5, if we attack with another character now, who doesn't hit for 6. Oh, it's a different instance of it. Crikey. Okay, not to... Actually, no. I'm trying to think why that isn't hitting. So how I've done this with like a before, and my understanding of it was that it's when that kind of equation evaluates, if the kind of returned value of that is changed, it's no longer true anymore, it would hit for you. It's the same with if it's false and then it changes to true, it would hit that breakpoint as well. But maybe I've made a mistake in my understanding there, or perhaps I set it up incorrectly as well. But yeah, so that's definitely another way that you can breakpoint. The other thing and the final thing, I'm not going to go deep into this, that you can do is you can set up data breakpoints as well. So to set up a new data breakpoint, you kind of need to be already at a breakpoint. But let's say we want to go here. We're already here now. We've hit this set at card game manager right at the start of the game. So I can add a data breakpoint. And what you can do is you can essentially just like watch the value of data, and whenever it's changed, you can do something. Now this isn't just for like bools, for example. You know, you could watch an object, or let's say a struct, for example, and you can watch it, because if that gets changed, any of the internal members of that change, then it would flag as a change. But typically we're kind of looking at pointers here, so or a particular value of a variable rather than bigger structs like that. So if you've got a flag which goes from true to false, you could always watch that value, and it'll always tick when it changes. If you've got an enum that is changing value, it will hit a breakpoint whenever that is changed. And it's really handy because you don't have to know where it changes. You can just go in and put it in and say, right, whenever something changes this, let me know. And you can then use the call stack to trace back to know, hey, where was that thing that I just I was trying to find out where it was changing. So typically to solve those problems, normally you'd maybe put a breakpoint in a setter of a function in order to know when it's been overwritten. But sometimes that isn't always the best solution, or it may not work for you because it maybe is getting set to the same thing all the time, and you want to know when it changes. So yeah, that can be super useful as well. But yeah, I think the more you use it, the more confident you get of when's the right time to use which tool. But okay, the final things we have in this debugging then is we have exception settings. Don't use that. Close that down. You have your output, which is the same as your normal output from when you're trying to build and compile, when you're not attached via debugger. This will give you your logs from in-game as well. So it can be handy if you don't want to trawl through the logs that you've got within Unreal. You can actually look here and you can do finds and stuff like that to find stuff. You can see there's absolutely a ton of stuff in here. A bunch of warnings. Shh. Our game works perfectly. It's fine. And then finally, you've got the bookmarks bar that I opened up earlier. So yeah, that's a very quick overview of how you'd use the debugging tools. The final thing I mentioned earlier that I haven't shown yet is I wanted to remind you that if I press this stop button, that will terminate it. And because I launched it via this, it would essentially mean that this closes midway through. And if you're in the middle of changing stuff in your level sometimes, so let's say I've just gone ahead and moved that, and then I go ahead and just press stop. It doesn't ask me if I want to save. It just completely kills the application. That can be a pain if you're not used to that process, especially if you've moved stuff and you haven't saved any level, etc. So what I want to show is that you can manually detach the debugger as well. In the same way that you can attach to it, and I'll show you both of these now, you have control about when to attach to it and when you want it to just be in control of its own kind of runtime, you know? So let me show you how this is done once this project is opened up. I forgot I go to this map every time. I never want to go to this map. It's just the example earlier. Okay, so we're in our game at the moment. Blah, blah, blah. We play the game. Let's get rid of some of these breakpoints. Okay, great. So let's say I'm midway through and I realize, right, I need to go ahead and make a code change now. So I might want to go ahead and do a code change. Let's just say bool test bool equals true. Great, really meaningful change. So I can save that, and if I want to compile my changes, like do a control B or whatever shortcut you end up using, you can see it says, oh, do you want to stop? You can't compile while you're attached via the debugger, right? So if you press yes, you're going to quit out, just like I showed you earlier. Isn't always what you want to do. So I'm going to say no. And what I'm going to do instead is I'm going to just press stop in here, just so we don't have the game running in the background again. And if I want to detach from that, I can go to debug, and you can use this detach to all. Detach from all, I should say, rather than to all. Doing that will just kill the kind of attachment that you had to any process that you were debugging. You can see that we've changed back to the blue kind of overlay kind of theme, so we know that we're not in the debugging mode, but our program is still running. We can still use it, which is great. So that's useful because sometimes you may launch your project from the Epic launcher instead. The only thing I'd say to be aware of is you kind of want the same symbols. You kind of want your code to be in the same state when you're attaching to it, because otherwise you're trying to debug something with code which doesn't line up to the version of the application that's running. So let's show you the opposite. If you want to then connect to it, so you can go to debug, and instead of doing start with debugging, that would actually launch a new instance of it. We don't want to do that. We can do attach to process. And within this will show you like everything that's kind of running on your computer. But if you just type in UE4, I think they tend to, yeah, there you go. And then you can go ahead and just attach to that. We change back to our kind of attaching overlay. It's loading the symbols so that it knows how to kind of connect what's happening in the game to our breakpoints and the code that's responsible for it. And now we're attached. So if we go back to our breakpoints and I chuck one in, let's just jump to begin play, shall we? Yeah, if we jump into here and we chuck a breakpoint. Oh, I know why it's saying this. Is this because I changed a file and I saved it, isn't it? Yeah. Okay, so I won't hit that breakpoint now. The reason is because I changed the code. Do you remember I added that if I do my Control-Shift backspace, I changed it earlier, didn't I? And so this code file, this is what I was saying to you, that you want to make sure that you're using the same code when trying to attach. However, I think some of the other code files should be the same still. So let's go ahead and just jump into a begin play in here instead. Now hopefully, yeah, can you see the debug symbol? If we compare them, it has this saying it won't be hit because it's different. There are some workarounds you can do. So you can go into the settings for it and you can say, oh, it doesn't have to match the source. And sometimes it will match up for you. But generally speaking, we want to make sure our code is the same as what we're debugging, especially if it's logic based. So let's go ahead now, and just to prove that we're attached, you can see now that I am hitting the begin play on that. I'm still not hitting this begin play because the code is out of date. That's okay though. So I'm going to hit this multiple times for every single card that's in the game. Excellent. Okay, so that is how you would manually attach to it and detach from it. Now, instead of having to close down the editor as well and then recompile my code and then relaunch it, if you are doing this process, like I said earlier, where we might want to make some small changes. What did I have this? I'll do another one now. Okay, so if we do that, and then we go ahead and we want to compile this, again, we're going to get a warning saying you're not allowed to do that. So okay, sure, I won't end my application, but I'll just detach from it. So you can stop debugging and you can rebuild that way, like I said before, right? However, not stop, detach is what I wanted to say there. However, Unreal does have the hot reload tool as well. And what that does is it keeps the connection between them while you're debugging, and it'll attempt to compile it. And in smaller projects, this works really well. But they kind of, sometimes the bigger the projects go, or the more complicated the code that you've done on it, it can get in the way of this process somewhat. So it's not always suitable, but normally if you're working in a solo project and you're not doing anything too intense, it will be fine to do that. So it'll compile it, and then you'll get an output message saying whether it was successful or not. Sometimes it'll just say hot reload failed instantly, and if that's the case, you have no choice. You've got to stop and relaunch it. But if not, okay, we've got failed. That means because there's a code issue somewhere by the looks of it. So times like this, it can be quite difficult to read here. So there you go. It says unrecognized type here. Okay, so these are general messages that you'd need to go and fix, and then you'd recompile it. Personally, in this situation, I prefer to close it, try and compile in here, and then use the nicer window that we've got, you know, our output window here, where we have slightly better tools to kind of work through and recompile. I would do that in that situation. But generally speaking, the hot reload is quite a nice tool when you're just making smaller changes. It can get a bit messy when you're working with blueprints. If you've got a blueprint open and then you add a new member into it and then you hot reload it, you can sometimes hit the odd breakpoint in the base code. But broadly speaking, it is quite a decent little tool. But right, yeah, that is the end of the debugging session as well. I was planning to go through a little bit on Visual Assist and that, but we've been going for flipping ages. This is 3 hours. I don't know how how we can chop this down to be a smaller segment, but we've gone over 3 things altogether though, right? So first off, we went over setting up Visual Studio. I'm using Visual Studio Community 2019. So setting up Visual Studio so that it's set up in a nice clean way with only kind of options enabled that you're probably going to use when you're coding with Unreal. Also installing Unreal VS, the extension that gives a couple of nice functionality things, and also just learning about what actually is useful when we're trying to navigate around different code files, whether you want to use the Solution Explorer or whether you want to go ahead and use some of the shortcuts to jump straight to files like the Control-Shift-T that we talked about earlier. We looked at functionality like what you would use when coding. So this is generally no debugging, not attached to a game, just general shortcuts and hints and tips and stuff that would help you with your general writing. This includes finding things, using the different find tools, jumping around different parts of the code base, using keyboard shortcuts, and just making sure that you're not wasting time doing something that could be done in an easier way for you. Making sure that you're not getting lost with all the different files that you've got opened when you can use your kind of back ability, or you can Control-Shift-Delete to go to the last place that you wrote code. Things that really just help you day to day to navigate a large code base easier. And then the final thing that we looked at then was debugging. We didn't do a deep dive into it, but we had a look at how the Visual Studio application changes when you're debugged, when you're in that debugging state, once you've attached. It automatically does it for you when you use this local Windows Debugger button. We learned that you can detach from it and reattach to it whenever you want. And then we looked at the different tools that we have, such as breakpoints. We had a look at using the call stack to work out how the flow of execution got to where it was. We looked at local variables, autos, and watch variables, so you can try and analyze the data at specific points. And yeah, we just generally talked about good practices of how you can use debugging to understand code, not only fix problems as well. So yeah, thank you very much, people, for your attention today. If you are interested in, again, the Microsoft Game Stack, you're welcome to check out the link there. If you want to just click on it, you can check out information on the different products that make up the Microsoft Game Stack. Visual Studio is just one part of it. I haven't got experience using a lot of the other parts of it, but as I do, then I'm happy to kind of share my experiences on those things as well. But yeah, hopefully people have got some benefit from the content today. You've maybe found out the odd little shortcut or tip or trick or something that's going to speed up your productivity, help you navigate your code, and help you debug what's going wrong in your games. But yeah, it's been nice to have everyone here. We're going to go and find someone to raid.